Buonasera a tutti e benvenuti a un altro evento di Graph Roma. E questa sera, come sapete, si parlerà di TigerGraph, ma prima di passare all'argomento della serata, come al solito, benvenuti e ci sarà una breve introduzione di qualche minuto. E per chi fosse nuovo di questo meetup, Graph Roma è un meetup organizzato da queste 4 persone, Marco, Piero, Enrico e Gabriele, che ci stanno ascoltando anche loro. E è un meetup dedicato ai dati connessi, per cui quelli che vedete qua sono solo alcuni dei temi che abbiamo trattato finora. Come vedete sono trasversali rispetto a GraphDB in genere come tema di questa sera, e si va dalla visualizzazione ai database con tutto quello che c'è in mezzo, per cui big data in genere, linked data e knowledge graph, eccetera. E come Meetup facciamo parte del Manning User Group, per cui abbiamo a disposizione un codice sconto che potete usare sul sito Manning per l'acquisto di tutti gli acquisti in realtà sul sito Manning. E come al solito, per chi si è registrato a questo evento verrà estratto il suo nome per un ebook gratuito e vi contatterò io quando sarete sorteggiati. Infine, questi sono i contatti per il nostro meetup. Potete trovare qui tutto quello che abbiamo, in particolare sul canale YouTube troverete la registrazione di questo evento e gli eventi passati. E voglio ringraziare Codemotion per aver messo, diciamo, per averci dato gli strumenti per il meetup. E detto questo, fermo la presentazione di introduzione. We will switch to English now, and the whole meetup will carry on in English. In particular, will come to the stage Mohamed and Bruno, who will present tonight the talk about TigerGraph. So I think, sorry, so Mohamed wants to say probably something.
Hi, thank you for being here.
And okay, so Bruno, you go first from my understanding. And okay, so I will go off stage, and whenever you want, you can tell me when to switch to Mohamed.
Okay, grazie mille, Marco. So let's start with the presentation. Thank you for coming and showing interest into TigerGraph, which is a graph analytic system. So we are not a graph database, but we are a graph analytic system with a database, with a graph database as in the background. With me today would be Mohamed. So he's located in Tunisia. He's our developer advocate for EMEA region. I am located in Munich, Monaco di Bavaria in Germany, and I'm solution engineer at TigerGraph. The program today would be basically showing you some specialities of TigerGraph, and then switch to a demo. And the demo would be split into two. I'm just going to show you some of the basics, and Mohamed is going to show you how you can basically change the schema, feed the data in, and do some small tricks with TigerGraph. So for the start, who is TigerGraph? So we are actually, this is our marketing, but it is actually true. We are the only scalable graph database for the enterprise in the moment. We are designed for both OLTP on OLAP workloads. We are somehow exotic on this market because we have SQL-like query language, which is called GSQL, and it's Turing complete. You will see how it works. We are cloud neutral. Actually, we are cloud native. We run in all 3 big clouds. And we were founded in 2012 with headquarters in Redwood City in California. but actually we were in stealth mode until 2018. So our first version of TigerGraph was released in 2018, and right now we are awaiting in 2 weeks for the version 3.2. So I'm assuming that everyone is knowledge is good in a graph area, and that you know what is actually a graph database. So just for your understanding, we differentiate between different graph, I would not say standards, but families. And there was an evolution of graph databases, starting with Graph 1.0, which was native graph storage, but was not able to scale out. Scale up is, of course, always possible until you reach the limits of your hardware. Then there was a Graph 2.0 based on something else than a native graph storage, mostly on key value store. And then there's a third generation of graph, which has all this, let's say, enterprise important features like very fast loading, parallel multi-hop analytics going to 10 plus hops, and so on and so on. We are going to see some of those features today. And independent of this generation of the graphs, we have actually two types of graph databases. Here, in this case, semantic and property graph. TigerGraph is a property graph. So basically, if you see here, we have both basically transactional analytics area combined in a property graph. So TigerGraph is basically here in the middle. So it can be very good applied for analytics and transactions. So this is actually very, I would say, interesting slide, because it shows on the first side what is the differentiator between us and some other systems on the market. So we are distributed graph database. So basically, it is a completely distributed cluster. So you can scale out almost without the limit. The limit would be only the number of machines that you need to put into the formula. So we can scale up, of course, can everyone, but we can also scale out. We can do deep link analytics. So deep link means something that is beyond 5th or 6th hop in a traversing. We have GSQL. It is Turing complete. You'll see what is actually the specific of it. We have even TigerGraph is not an open source product. We have a free edition where you can run and store up to 50 gigabyte of graph data for free, of course. But all the algorithms that we are using are provided by GitHub, and they are open source algorithms, like our connectors and so on and so on. So we have something that's called multigraph. So it's a multi-tenancy. I'm going just to show you something around this. We have Graph Studio. Graph Studio is our visual SDK. It is the first purpose of it is to have to support developer or data analyst in developing the graph. Then we have a very good data compression. So it means here is approximately 50%. In some cases, we have even 75% compression. So it means you can put, instead of, let's say, 50 gigabyte of raw data, you will be able to put, it would take 20 gigabytes of data in TigerGraph. We have machine learning feature generation. This is possible with GSQL because it's Turing complete. So you can have in database machine learning enabled. Why is this so important? Because your data is not leaving the database. So there is a security aspect of it. You are always running on a system or a single system, which is very well protected. You don't export the data to some external systems where they have to be parsed and computed and then putting it back to the database. So everything is done in our database. The first thing is, of course, security. The second thing is latency. So you don't have export, import, and so on and so on. You don't lose time. So you can actually use almost real-time machine learning if you want. And the third point here is the possibility of errors that you could have, because all the transportation of the data means you have a network, and if you have the network a brokerage, then you will have a problem with the data. So it's not error-free. This having it in database means that it is actually almost error-free on this side. And we are ACID compliant for both OLTP and OLAP. So this is just the overview of basically everything. So what I said until now, what you're going to do, you will get this PDF if you want it for download, so we can distribute it to you. And there are some useful links at the end of it. And I think this may be a good way to dig deeper into our technology, because we are not going to show you everything today. So how is the architecture actually built? It's a, let's say, very modular system. This is the core system of TigerGraph. We have the ETL data loader. So basically, when you get data in, you can use ETL process to transfer the data. So you can actually get JSON data and do some transformation on it. You can use CSVs, you can use REST API, and so on and so on. We are using internal message queue to push this data that you load over multiple machines in a cluster. So this is internal. This is not the Kafka that you would use maybe to stream data in. We have a graph storage engine and graph processing engine. So this is a distributed system for store the data in our proprietary format, which is compressed on one side. On our other side, we have query processing, which is actually taking care of data snapshots and GSQL processing on top of it. We have REST-PP, and based on REST-PP, you can have, let's say, multiple ways to connect. So you can have RESTful APIs here. It is also used for GSQL servers, so you actually can start GSQL queries and get the data out. This is something that we are going to show you today. And Visual Design UI, this is the Graph Studio server, which is going to be shown. How to, or what kind of data you can get in? It's all kind of operational data, all kind of master data. TigerGraph is not a system which is to replace something that you already have maybe in your infrastructure. TigerGraph is a system of to extend or aggregate your multiple data sources into one system and do very performant analytics on top of it. And of course, you can use different kind of outputs to consumer data and to get, let's say, data analytics, and use some visualization tools and so on. Some of these parts you're going to see today. So the data pipeline, normally you will use something like file system, or start at least with it. So with HTTPS requests, then of course you can use Kafka for data streaming. You can use AWS S3 for data source. Even if you're using Azure, we can use a binary store of Azure. We can use Spark and JDBC driver, and all of this comes into TigerGraph. It could be transformed on the fly, let's say it like this. So you basically just have to provide the data, or your customer has to provide the data in a raw format, and then the whole transformation would be done in TigerGraph on a very performant way. And on the other side, you write a query. This query can export let's say, the result into a file system, back to S3 if you want, or you can consume them using REST API, and then using one of the, let's say here in this case, PyTigerGraph, but we also have the possibility of connecting with JDBC or HTTPS requests for additional services that you may have. What is GSQL? GSQL is Turing complete, so it means declarative and imperative programming language. Differentiator between, let's say, some other systems using Cypher would be with Cypher, you're declarative, but you're not imperative. To be imperative, you will need something like Gremlin on top of it. And you have here in GSQL everything from a single hand. It's a SQL-like. Of course, if you know SQL, it will be easy to learn and understand. There are some specific things that or functions that a SQL language is not having, like in our case, accumulators. Or accumulators are just the variables, or let's say more pointers or collectors, buckets, whatever you want. From they can have different types, and they would actually collect the data and traversing, and then you do processing on top of them. So you can do some math operations, or you can even create a new GSQL query to import, to insert or update or whatever you want to do with the result of it. It is compiled. You can actually, for the testing, you can run it without compilation. In some cases, you need to compile, because if it's using UDFs, then you have to compile it, for instance. So basically, you can optimize by compilation in the background. So it would be a binary in the background. So we have some pre-installed graph libraries like PageRank, community detection, and so on. So it is it utilizes the control flow statements like if, then, end, and so on and so on, or and data modification, like I said already, delete, insert, update. Includes various functions, so for mathematical string date, like you know it from other. What is also important, it can be distributed. So GSQL, you can start it from a single server, and you can start it distributive. If you start a distributive, it's going to spread all over the place, so in your cluster, and ask every single instance for the data, and it will join it basically in a single instance, and your client is going to get the very performant response back, because it's not asking every single system in serial. It's basically spreading the information or the query to all of them and getting the data back. Then another function that is very specific to TigerGraph is multigraph. So multigraph is basically multi-tenancy system. I'm going to show you in this small demo what we have, what is actually hiding behind this. So it supports multiple tenants, but in a single database. And so this is basically how we do this. So you have a single master graph, and then you can actually have some data that would be shared between, in this case, different departments. So on this case, you have fine-grained security, of course, on the top of your vertices and edges. In this case, actually in vertex, because if a vertex is not included in your multigraph part, then the edge which is connected to it is not going to be there anyway. So that's actually from security perspective. So what is a Graph Studio? It's our tool for developing the graph database. It's a basically browser-based visual SDK, and you can do different things, of course, with it: schema design, visual graph exploring, query writing. So we are going to show you this, result inspection. And what we have actually is this is just a screenshot of it. It's a visual query builder. So it's still in beta. It's online, or let's say released since version 3. And it enables you to start building your queries without need to learn GSQL. So it is actually targeting more data analysts who would like to do some querying, but without learning GSQL, or maybe they don't know SQL at all. So this is actually very easy way to put these functions or queries together. So this query would be compiled in the background, and then you get actually a full functioning query for your purpose. And of course, what you can do here is also the TigerGraph using user-defined functions. You can define those functions in C++, put them in a specific file, in this case, expression function.hpp, and you can call those functions when you start GSQL queries. So basically, you see we have here two functions, UDFs, greater than 3, and then reverse. So basically, I can use those functions as UDFs directly in GSQL query. And this is, of course, a very fast alternative to some operations that you don't want to write in GSQL directly, but you would like to use C++ and the benefits it is having on a server side. So what deployment options we have? We have the possibility of running on a bare metal servers. It's Linux only, so we only support Linux. You can download ready-to-go virtual machine images, or, which is here missing, I don't know why, is Docker container. So you can use a Docker container for development. You can use basically then import and export function to transfer those schemas and queries to your, let's say, cloud installation. So, and there is also the possibility of TigerGraph Cloud. So next to this, or let's say in addition to the cloud services at the AWS, Azure, and Google Cloud, where you go to the marketplace, TigerGraph Cloud is a database as a service, or let's say system as a service. It's fully managed, and it includes 20+ starter kits. I'm going to show you this. So what is here missing is a Docker container, and if you want, I can send you how to set up a Docker container with Docker Compose. I provide for TigerGraph Docker image, which is having two functionalities that are not currently enabled in our official Docker image, which is the auto start and persistence on a host drive. So basically, you can mount your data folder from the Docker container to the host, and it's going to be auto started. This is, like I said, my image that is sort of just for developing and for testing. It's not TigerGraph official image. And how to start? You can start for free using TigerGraph Cloud. This is under tgcloud.io or tigergraph.com/cloud. You will see a portal, so you can log in and then basically start one of those solutions. I'm going to show you actually in a demo now how it works. So let me check another screen. And this would be, if I found it, here. So we have a dashboard. Oh, I still have some money here. And if you want to provide a new solution, then you go and create solution and take one of the starter kits. So you can actually filter by starter kit here. What we do today is we have our movie database. I think it's this one. Go to next. And now you have actually the only free tier that you can have is on AWS. So you will have to select TG free. If you go to Azure or Google Cloud, you see it's not free. So we are currently in discussion with, or negotiations, I would say, with Google to enable us TG free instance on Google Cloud. Then you check your region. So let's say here, Frankfurt. You cannot change disk size or anything else using the free instance. Partition factor and replication factor in this case would be actually the distribution. So basically it would be distributed into 3 partitions, means partition factor 3. So I will have at the end 3 machines for this cluster. Replication factor means 2 copies, 3 copies, 4 copies, depending on how deep you want to go into high availability. So this is a partition, data split, and replication is about high availability. So if you, let's say, have three nodes, also 3 servers, you will have to at least to have 3 data copies for this. So let's go on next. So you just name your solution. You can tag your solution. You have to set your initial password, because if you forget it, you can kill the instance, and that's it. You are not going to get it back. And so you need a password here, and you have to note your password for this. Subdomain would be something that you define. I actually have, for this meetup, I defined the subdomain meet.i.tgcloud.io, and then you just put the description here. Let's do some passwords, so I can go, let's go test meetup to go further, and then you will see what's actually happening, and you will see that there is a price per hour is 0, and you're not going to be charged at all. Press submit, and then the instance would be started. The downsides of free instances are, if you're not using it for 1 hour, it's going to be stopped. If it's stopped for longer than a week, it's going to be terminated. And we are not making any backups for free instances. So since we have already a solution, what I'm going to do is actually, it's already started. So I'm going to go into Graph Studio, and Graph Studio would open this solution that we prepared to show you today. So we have now a global view, and we have a database view. So the database view, what is the difference? The global view is basically something that you would use if you would do a multigraph. So check the schema, which is very simple. In this case, we have a person and a movie, and we have an edge rate. So if I would like to, let's say, do a multigraph, which would only have a person in it, I can go here and create a graph and say multi-person, and I would say just a person. That's it. So if I create the graph here, I see only the person, and I can show you then, or you have to believe me if I'm not going to show you, that I'm only seeing the persons here, and I would not be able to see the whole graph schema. So this is how multigraph is working. Of course, in this very simple schema, it is not very interesting. So how to do the map data to graph? So basically, what we did here, we have the CSV files which are mapping the data, and then if I click here, then I see there is a primary ID going to the ID, or here in this case, I have the rates, and see what the person was actually on one side going to movie, and then the rating and the date daytime, which it was the rating was done, and then on this side how the vertex movie is done. So what we can do is explore graph, and I will say, okay, you have now the possibility of picking 5 random things here. In this case, we have just let's say persons and movie. If I would like to get the movies, so just pick random movies, I will see them here, and then I can double click on it and see this movie is a confess, and it was rated by this person, these 2 persons. So what I can do is basically click on this side, on this person, and then just force layout so I see a little bit more, and then get the data. So this is basically just doing a manual process to connect something. I mean, we have the possibility of checking here, do the expand on everything. So this is what I was doing now with a double click, or I can actually find parts between 2 vertices. So I can say, check the movie, I don't know, 260, and check the movie 188. Let's clean everything here and see, going through every connection here and one shortest path. So let's see if there is a path. Oh, okay. These 2 movies were rated by this person. So this is a Prophecy and this is a Star Wars. So this basically this is how it works here. Let's check a little bit to the queries. We have person and movie, very simple. So if I could use this. So 359 is my person. So I can check the recommend movies and I can see what was it? 359. Okay, 359. So let's do this. Person 359. Let's do 10 here as an integer, and this is 5. And then run query, and then I will see. Okay, this is basically the movies that were so the 5 movies that were scored by this guy. Or I can use something like similarity, and this similarity is based on a connection. So it's not based on attributes of the movie, it's based on solely on the connections. So what we will have here, actually, when we are looking for the movie, we are going over the rates and then to the person, and basically the idea is to get similar movies over the persons that were rating them. Of course, it works the best when you have a very complex schema and you have more than, let's say here, one edge. But let's do this let's check the movie first. Let's do 260. We did, and I would like to have 5 movies here. And if I run the query, I will see that there is a Star Wars. I have here Riders of the Lost Ark, Star Wars, Matrix, and Back to the Future. So basically some similarities here, right? And how we get the results basically is on here. So we have, let's say, attributes. So we have similarity 0.63 here with Star Wars Episode 4. It's a 0.5, 0.545, and so on and so on. We can use the same system to do a person similarity. So I can actually get, let's say, 138431. I know this person is existing, that's why I'm using it. So, and then I will get, let's check something. So if I expand this guy and I expand this guy and see actually the connections that those 2 guys are having, you will see that we actually have a very good intersection of the queries or of the results here. So this is actually the part that I wanted to show you. And I think that Mohamed is going to show you now how to use it more dynamic than I did.
Thank you. So this is the graph that Bruno has been showing. What we are going to see is how you can manipulate and load data in a low coding way. For that, we will demonstrate this session using Node-RED. So if you're not familiar with Node-RED, Node-RED is a flow charting language created by IBM engineers. So it's nothing but nodes and links you can program visually with the least amount of coding possible. So with that, we have nodes for TigerGraph, and these nodes are now available on NPM and Node-RED and TigerFlow too. So you get the chance to install Node-RED and install it from the palettes. So if you go to Manage Palettes and then you click Install and you search for TigerGraph, you will find Node-RED TigerGraph. You install that, and you will get the palettes for TigerGraph, which are the basic data modification nodes. What we will be doing is we'll be expanding this graph and adding values to it from Node-RED with the least amount possible of coding. Of course, anybody newbie to TigerGraph will have time to get in sync with GC calling the syntax and everything. So let's see each and every step in a low coding way. So what we will do is we will list the schema, and then we will create a schema change job in which we will add a new vertex called description. That vertex will be hosting, or we will load into that the movie description. So our data set right now has a person and the rating for a movie, but we don't have the movie description. What we would do is we would use Node-RED in order to get the description of that movie from IMDb using Google search, and then observe or transfer that data automatically in the background as a service into the new vertex created. So if we go step by step, and this query will be running ls, and anybody from the Unix world, ls means listing, so that's pretty much straightforward. We get the output saying that our graph has the vertex person, the vertex movie, and the edge rate. That's it. So if we go to the next node, we'll be adding a schema change job saying that we will add a vertex called description and an edge called movie description. So when we create that schema change job and we run it, there you go. The schema is created. If we go back to our graph, refresh, we can see that we have a new vertex called description. So this description vertex and the edge linking back to movie has been loaded from our Node-RED, and then we can drop the schema change job. This is optional, but a little bit house cleaning. So if we list again our schema, we would find that we have, okay, so I'm facing some network lagging issues, but it will respond. So meanwhile, I'm going to create a new query that we will be using in the process. So the query is selecting maybe 10 elements from the movies, and we'll be looking for those 10 elements using Google custom search engine. So when I inject that and I install that query, I can see in our Graph Studio that, yeah, so it's my network lagging right now. I should log out and then log in. There you go. So this is our script, select 10, which will select from our graph 10 movies, and then we'll return the result. As you can see here, the query is pending installation. So once it's installed, that means it's compiled. It can be run using pressed endpoints like this one, so you can curl it remotely. That's the architecture phase that Bruno was demonstrating earlier. So a query can be run from GSQL terminal internally, or can be triggered using REST PP endpoints that's using curl or any software or middleware you can use. We provide multiple connectors, and one of these is Node-RED in order to manipulate your data. So if we run this from our Graph Studio, we see that we have 10 vertices, but if we go to the JSON viewer, we'll see that we have an object of result containing IDs, types, and different attributes. So we do have like MCQ, brother, and so on and so forth. Going back to our Node-RED, we get to execute the same thing. There you go. These are the responses from all the actions that we have triggered, but it was a certain glitch in my network. So going back to our graph, we can execute that query, select 10, which doesn't accept any parameters since it's void. Once we run that, it will return an object containing the same preview that we've seen, object of arrays, and each array will contain a movie and its attributes. We can do this visually using an HTML page, and then we go to the endpoint of /movies. So I can copy paste the address and then add movies to it, and I will have like this HTML page, and I can like do parallel KB maybe, and I get the response saying that this is the description tagline, prepare the blown out of water, and the journey, and everything from IMDb directly. Or we can do this as a service, and this is the interesting part. So if you're going to make your data scalable and auto ingestible, you have to do is to get the output from the query. So now we're selecting 10 elements. Now we need to format that. So formatting this data will be done by this way. We will recover the output object. This will be a list, and we'll be iterating over that list each and every time, taking the movie name from the database and the ID. And then we'll be calling the Google search engine from this custom URL, and we'll be sending this to the next node. So we'll be sending 10 requests. And of course, so that we can't be banned by Google, we're limiting the rate for 1 message per 5 seconds. Then we are setting up the message URL from our payload from the function node. And finally, we'll be calling Google endpoint in order to get IMDb description. Once we have the response, we do know that Google sends the items snippets like this one. This is a preview of the result. So I am searching here for the butterfly effect and the response items. We do have snippet here saying that the butterfly effect was directed by Eric Bress. So this is our description maybe. We take that element snippet and then we send it over to the next node, which is the function that would be sending it to our database. So to send it to database, we need to do matching, and the matching is done by linking the incoming message with the appropriate attribute. So if I go back to the graph here, we do know that our movie has ID and title attribute, and our description have ID movie and description text attribute. So I need to prepare a JSON object containing ID movie and description text for the vertex description, containing the response from Google, which is snippet, and the message VID, which is our movie ID. And then linking that back to our graph is done by the edge movie description, where I should match the ID movie with the ID of the description I have. Once I return this message, that will be flowing to the next nodes, which are our connector nodes. So the first one will insert to the description vertex, and the second one will be absorbing the edge description, movie description, by doing the matching attributes as usual. So when I click trigger, you can see here that we are requesting each 5 seconds, we'll be requesting a new movie, sending it back to Google, getting the description, loading it back to our graph. So if I go to load data, we can see that our description here is being increased. Now we have 2. And if we can go to explore graph and select description, which is our new vertex, we can see that we have movie piping in like this one, Takashi Kitanao, something like that. Links are done dynamically, so we wait for the database to ingest the edge linking, and now we do have this movie, which is Roxy Hart, has this description, Ginger Rogers and something from Google, and these are the people that liked it. So with this flow here, we can see that we can extend our schema seamlessly as a web service, as a web interface too, and we can call it as an API. And of course, this small schema we have can be more expendables by maybe getting values from like Wikipedia dynamically, inserting like the box office value of this movies. And this will be automatically inserted back to your graph. And the advantage here that Node-RED will act like a service, as a backend service, and you get to execute all the basic data manipulation, like listing, absorting, executing queries, and installing them. So the service now is ended, and if we go back to our graph, load data, we can see that we have 10 description vertices. If we get to execute that, that will execute another load of 10 other vertices, and so on and so forth. You can set it like a cron job, or call it via trigger, or even make it call itself each and every period of time, like by acting on the inject, saying that I will inject or repeat this each interval, and I will set up the interval period. So that's our small demo. And if we go back to our queries for the GS similarity that Bruno was showing, having more complexity of data will help getting more efficient results. So as the graph expands in schema, you can get more and more efficient results. So going to the person similarity, let's take the 5 persons that looks alike. Now we can know for sure that these people has rated maybe more or less the same movies. So by doing this, we can see visually that they are interlinked, and this can be done using regular relational databases. Thank you.
Thanks, Mohamed. Thanks, Bruno. We collected few questions if you would like to answer. First one I see is for Mohamed, and is asking, are those templates, I think from Node-RED, available for use? It looks a bit tricky for the visual pipeline to Google API. So do you offer also some templates for Node-RED and TigerGraph?
Yes, actually, we do have the TigerFlow, which is a rebranding of Node-RED available on Docker, and we will be shipping with the document that we have for the presentation some learning materials that has the templates we've been showcasing.
Okay, okay. I hope that answers 09 question. Gabriele is posting few questions right now, and well, quite technical. Do you follow the free index agency property in your GSC? Do you write just the properties indices defined by the users, or you also store the neighbors' IDs?
So basically, we have 2 indices. We have internal index that is storing a hash of the vertex ID or connected vertex ID. So basically storing the neighbors too. This is the edge storing basically those. And you have the possibility of defining your own index in a SQL manner. So you can actually index your string fields if you want to search for something. It is, to be honest, TigerGraph is not a system where you would actually use for searching over index. So for this, we have, let's say, solutions or customers using us with, let's say, Elasticsearch. So you will use basically application to connect those 2 functionalities together. On one side, using analytics, graph analytics with TigerGraph. When you get the IDs, then you can use actually the search on other side, or vice versa. So I always tell to our customers, don't try to do everything with a single system. Mostly it's not working properly. Just if you're using the system combined through an application, anyway, why bother? So use 2, 3, 4 different systems that are connected over using let's say IDs or some other items to connect the data.
Okay. I hope this answered Gabriele's question. I'll post another one. Yeah. This is interesting because usually graph databases are marked as schema-less graph applications or databases are marked as schema-less. So his question is it possible to work in a kind of schema-less or schema hybrid mode in order to get more flexibility while handling a structured data?
No, currently not in TigerGraph. So basically, we have a static schema, which you can change very easily if you want, like you saw Mohamed showed you how to do this. I mean, it is always a sort of, I would say, trade-off. I was working previously with Couchbase, and Couchbase it's a document database, so it's a schema-less and so on and so on. If you want to do, let's say, sort of analytics based on documents, you need a kind of schema, because you want to know where it is. Even if the schema would be just an index, you know, then you do actually on one side storing the documents schemaless format. Bless you. On other side you use on other side you use index to actually create a hybrid of the schema on top of it to be able to use this analytics or search optionality. So since we are analytic database or analytic system, we need a fixed schema to be very fast. That's the benefit here.
Okay, makes sense. But do you have in plan to also extend it to schemaless, maybe for other use cases? Or
yeah, that may be actually possible, but now we would like to do some, I would say, more important tasks like getting Kubernetes to work not only for the single instance, but to have a Kubernetes cluster supported and so on and so on. So there are some movements into, let's say, fully cloud native system. And this is where we are now actually investing a lots of energy, lots of time, and lots of resources. And then let's see what's going to happen. I mean, you know how product marketing is or product management is working. They would tell something, and before the release is out, they will say, no, we didn't make it, and then it's not worth of telling it. But I think it's going to happen somewhere down the road.
Okay, makes sense. I have just another couple of questions. One is specific to a use case, and it's how can you do data science with TigerGraph? Do you provide specific tools or documentation for that?
Yes, basically we have this library of different analytic functionalities. There are some very good documentation around Jupyter notebooks and integration in it through with using our PyTigerGraph connector. What else? Basically, it is a tool for data analysts. Yeah. So everything is what you. Yes,
sorry, go ahead.
No, that's.
Is there any plugin ecosystem around that, and in which data science falls, and in general, where anybody can contribute to that?
Yes. So actually, we're working on publishing some sample notebooks using TensorFlow and many other libraries of machine learning and everything. Yes, the plugins, it's feasible. We're working on that using not only the Python driver, but also all the connectors we have. So you can do Node.js, Python, even basic curl requests or Postman. So we are in the middle of releasing that, and stay tuned. We will, if you stay around in our community Discord server, our own community forum, you'll be noticed when we have that available.
Okay. I think this answers also another 09 question, which is about custom scripts and plugins.
Yeah. So basically, custom scripts would be written in GSQL, because GSQL is Turing complete. So basically, you can use whatever you would do in a programming language, but in a connection with a database. And then you call this like Mohamed showed you previously. You call this using REST API point, for instance, and that's the usual way to do this. We have lots of let's say customers using us with Python, because Python is sort of now machine learning enabler language. So this may be also a possibility to use basically Python and doing machine learning in it and connecting it to the results that you get from TigerGraph. So it's very flexible system. It's very open.
So just to understand, because before you talked about C++ extension.
Yes.
When you mention Python, you say something on top of JSQL, not like an extension of JSQL. Is that right?
Yes.
Okay.
Yeah, it's on top of JSQL. So basically, if you go through the hierarchy of how this programming language would work, you have UDF in C++. Then you have GSQL, which would be using the UDF, and you have a Python with connector, which is going to use the GSQL and combining the Python possibilities that you have in Python with JSQL results that you get from TigerGraph.
Okay. I have just another question, actually, in topic, because you talked about extension in C++ and of the language of JSQL, and as we may know, C++ is not like the simplest and so nice language to write. I mean, to test, to maintain in general, maybe to write, it's fine. Do you plan to have some sort of to extend the support to other languages, even like a couple more user accessible, say something like Python, or like even a custom one like other database offer?
Currently, I think it's going to stay like this. We support REST API, and so you can connect to TigerGraph using REST API. The idea is to have this core system, which is doing the whole analytics I would say in a closed ecospace, and then you get the data in and out using REST API. So you have, let's say, it like a black box with GSQL around GSQL, and then you have the possibility to consume this by various tools. Why we are doing this is we are actually a distributed system. So we do this massive parallelizing processing, and we do the distribution. And it's very hard to do this if you open the system to something else. You have to take care of snapshots over different cluster parts. You have to take care about distribution of the queries and so on and so on. So basically, it's impossible to do this. It's very hard to do this on the way we are doing right now. So we have it's not perfect, but it's working. Let's say it like this, and opening to some other tools that are maybe not done for this. It's going to create lots of problems. What we are going to do is we are part of this GQL. What is the name of the consortium? Yes, thanks. So there are a few things that are going to be transferred from GSQL to GQL from our side, and I think eventually in 2-3 years those two languages are going to merge together. So this is the part where we are now also actively developing something. Okay, makes sense.
Just sorry, one last question is, you mentioned the REST API. Do you offer also a streaming protocol or a streaming kind of research to consume the results of the query?
Not directly. So what you can do is basically to have there is a Kafka add-on for file system. So basically, you will push the data to the file system somewhere, and then from there on, you will have a Kafka consumer that is going to push it on the streaming. So the streaming right now is going only in one direction. So this means into TigerGraph directly without need of some workaround. Okay, makes sense.
I did read all the questions I collected. Don't know if you want to say anything, because we came to an end. So, I mean, from our side, thank you for doing the talk. It's been really interesting, and I think it's really interesting to compare TigerGraph as graph platform compared to other competitors, understand what are the differences. It's always useful. I see you're showing research, so I'll share it.
So we prepared some resources that may be very helpful to you if you want to start with us. So you saw that there is a free instance of TigerGraph in the cloud. If you want to ping me, my email address is bruno@tigergraph.com. Just send me an email, and I'm going to respond you with a how to use Docker container, how to use my, let's say, personal Docker container. I think it's easier to consume it, and it's not very very complicated. So this would be the basically some of the information that you could get, this is our graph algorithm library. We have some templates for this. You can modify them. I was just using this Jacquard similarity to produce what you saw with a similarity, which is very, very, very simple. So this is it from our side. Thank you very much that you were here, and I would be glad to see you somewhere around, maybe on site with a pizza and beer next time, or wine, whatever. Yes, and we are still hiring. So if you would like to be a part of TigerGraph team, we I think have even some positions open in Italy. Give me a ping, call, whatever, and then maybe we will be new colleagues. Okay. That's it.
Okay. Mohamed, you want to say anything?
Yep, I would like to thank you all. And yeah, as Bruno said, looking forward to have this again, and why not be repeating this in live with you.
Yeah, we all would like to do that, really, after all this time. So thanks again, and thanks to all the audience who has been sitting with us and watching the recording. And I'll just say switch to Italian just for a second, per augurarvi a tutti buona estate, e ci rivediamo da settembre con Graph Roma. Detto questo, buona estate, buon luglio, buon fine luglio, e arrivederci a tutti.
Arrivederci, ciao.